Hi everyone, it's December 5th, or December 5th, ay, ay, ay. It is December 1st. Happy December. We only have 25 days till Christmas, so hopefully your Christmas countdown calendar got changed on the board. You should have your algebra book out on your desk. You should be turning to your homework from yesterday, which was pages 7 through 10. We did page 6 together. You need to have something out to write with. Hopefully, you're sitting in your assigned seats. As a reminder, I'm going to be out until next Tuesday at the soonest. And so we have to continue on with our learning. And so we're going to be doing it via Screencastify here for the next few days. All right. So, what I would like you to do is just get situated. Go ahead and pause the Screencastify. And as soon as everyone has their algebra books out and they have turned to page 7 through 10 and have their writing utensils, feel free to start it back up. All right. So yesterday we went over the solidifying task of discrete. Please be discrete. And we did the books, the Library of Congress books. In the library, we made a table, a graph, and an equation in the Screencastify. And we had talked about that new vocab word domain. Then we went on down to the second one, which was the ebooks. And we made another table, graph, and equation, and we talked about the domain of that function. Your homework was to be doing page 7, 8, 9, and 10. There was quite a bit. So we're going to go ahead and get started. On number 3, it says the librarians work to keep the library orderly to put books back into their proper place after they've been used. If a librarian can sort the shelves 3 books per minute, so there's our two variables, books and time. How many books can the librarian take care of in 3 hours, 5 hours, or in hours? All right, so here's something that we need to kind of look at. This is in minutes, but they're wanting their answer in hours. All right, and so we're going to have to change from minutes to hours at some point. So make sure we're critical readers. So use a table, a graph, and an equation to model this situation. So I went ahead and just said at 0 minutes, they did 0 books, 1 minute, 3, 2 minutes, 6, 3 minutes, 9, and so on. We know time is our independent variable. Time doesn't stop. It doesn't matter how many books you do, but books depends on your time. So your books is your independent variable. Okay. I went ahead and I just sketched out a graph. I put minutes on my X, books on my Y. I decided to go by 5s, 10, 15, 20, and skip 1, 1, skip 1, 2, all the way through. This is a linear graph. I did not connect the dots because even though my time is consistent or constant, our time can have those increments. Books have to be whole increments. I have to have whole number of books, 1 book, 2 books, 3 books, 4 books. Okay. My equation so far is 3x plus 0. So it's 3 books per minute or just 3x. But if I need to convert that to hours, I want you to push pause and I want you to talk about if it's 3 books per minute, and here's my equation. If I want to find out 3 hours, what am I going to do to this equation to change it to hours? What would that look like? If it's 3 books per minute, how can I figure out how many per hour? Go ahead and pause the video and have a quick discussion with your seat partner. What would that look like? All right. I'm not sure how that went. Hopefully, you turned and talked to your seat partner. Hopefully, you found out that you can convert this minutes, this X to 60 and for an hour, or you can convert it to 120 for 2 hours, something like that. Maybe you came up with some different ways. All right. The next question asks, would it make sense if any of these situations for there to be a time when there's 32.5 books to have been shipped, downloaded into the computer, or placed on the shelf? So basically, they're thinking about problems 1 and 2 from yesterday and 3 from today. And they want to know, was there any time where it makes sense to have 32.5 books? And hopefully you said yes, you can have 32.5 books downloaded. I'm not going to really rip a book in half to to ship it, or I'm not going to have half of a book that I'm going to put back on a shelf, but I can have half of a download. So half of a download would make sense. Continuing on to number 5, says, which of the above situations, problems 1, 2, and 3, represent a discrete function? Remember, that's our new vocab, a discrete function. That would be those whole increments like the video we watched. And which would represent the continuous function? And so we touched on it quite a bit in our last video, but problem 1 would be a discrete function because we can only have whole books. Remember, problem 1 up here was when there was 8 books per box, 8 per box. And so you're not going to ship partial books. And so that is discrete. We have to have whole numbers. All right. And then problem 2 was the downloads, and you can have a partial download. I can have 32.8 books downloaded. I can have 46.7 books downloaded. So that would be considered continuous. And problem 3, again, that's when they're putting those books back on the shelf. That was right here. They're putting back 3 books per minute. They're not going to put back a partial book. So again, that one is going to be discrete function. All right, we're zooming right through this. Heading on down, number 6 says a giant piece of paper is cut into 3 equal pieces, and then each of those cuts into another 3 equal pieces, and so forth. How many papers will be around after 10 cuts, 20 cuts in number of cuts? Use a table, a graph, and an equation to model the situation. All right, so I just kind of went through it. I thought 0 cuts, I had 1 piece of paper. After 1 cut, I had 3. After 2 cuts, I had 9. And I noticed once I started making a table that this was changing exponentially. It's going to be a geometric equation. Okay, so 0 is 1. After 0 cuts, I had 1 piece of paper. After 1 cut, I had 3 pieces of paper. 2 cuts, 9 pieces of paper. And if I continue this on, I notice the pattern is changing by times 3, right? There's my rate of change right there, times 3. So 1 times 3 is 3, 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. All right. So I decided I'm going to make a quick graph. My number of cuts is going to be my X value. My paper pieces is going to be my Y. I went by 20s on my scale here and 1s on my scale here. You could have gone by whatever you wanted, but it was definitely 1, 3, 9, 27, 81. It's definitely a curved graph. Okay. And my equation was f of x equals 3, my rate of change, to the power of x times my start of 1. So here's my question. Here's where I really want you guys to pause the video and make sure that everybody is included and has a partner and turns and talks. Should this be connected? Should this be connected and continuous? Or should it not be connected and be discrete? What are your thoughts? Can I have a partial cut of a piece of paper? Can I have a partial paper? So if you think it should be connected, I want you to talk to your partner and tell them why you think that this should be connected. If you think it's discrete, I want you to justify your reasonings why. And go ahead, and it says identify the domain. Well, our domain is positive something numbers. They're either positive whole numbers if you think that it is discrete, or it's going to be positive rational numbers if you think it's going to be continuous. So I just want you to justify. I don't think there's a right or a wrong answer here, as long as your justification matches. And then go ahead and talk about C. Would it make sense to look for the number of paper cuts of 5.2 cuts? Would it make sense to look for a number of cuts that makes 53.6 papers? And why? So I want you to go ahead and just turn and talk to your partner about this section right here. There is no real wrong or right answer. It's kind of in your perspective. And I'll go ahead and pause the video and talk about that. All right. Hopefully you had a good discussion there. I'm not going to say one way or the other. I think that you can make a good justification for this to be continuous or discrete, depending on how you look at it. But we're going to go ahead and go on It says medicine taken by a patient breaks down in the patient's bloodstream and dissipates out of the patient's system. Dissipate means like dissolves or is taken out of. Suppose a dose of 60 milligrams of antiparasite medicine is given to a dog and the medicine breaks down such that 20% of the medicine becomes ineffective every hour. Okay, so we have time and hours, and we have this parasite medicine. These are the two things that we're comparing. 20% of the medicine is ineffective every hour. So it says how much of the 60 milligram dose is still active? Ding, ding, ding. Remember, we have to be critical readers as we're going through this. And so as I'm reading this, I realize that it says they've given me a number 20% is inactive, but they want to know how much is still active. They don't care how much is inactive. And so I started to think if 20% becomes ineffective, and then it means that 80% is still active, right? If 20% every hour becomes ineffective, then 80% is still active. And so be careful. Even though 20% is ineffective, it's asking us how much is still active in the dog's bloodstream. So instead of using zero point 0.2 for 20%, we're going to use 0.8 for 80% because that's going to be how much is still active. So at 0, they get 60 milligrams. And when I multiply 60 by 0.8, how much is still active? There's 48 milligrams still in his bloodstream after an hour. If I multiply 48 times 0.8, 80% of 48 that is still active after 2 hours is 38.4. Going to continue that, multiply it by 0.8 again, multiply it by 0.8 again. Go ahead and if you need a calculator, double check that math, but it's just multiplying by how much is still active. Okay. I kind of sketched this quick. I noticed that it is a curved graph, and I can connected these dots or these ordered pairs because it doesn't go straight from 60 milligrams active to 48. It doesn't jump at the hour. It's dissipating. So it hits every value in between. So it needs to be a continuous graph that is connected. My equation f of x is equal to 0.8, that 80% per x. It is geometric, so it is an exponent, it's exponential, times my start amount that I gave the dog of 60 milligrams. So it's 0.8x times 60. And the domain is these x values. They're all positive. You only can have positive time, and it's going to be rational numbers because it's going to be all the decimals and fractions in between. Okay? And the question asks, would it make sense to look for amount of active medicine at 3.8 hours? Well, yeah, maybe I want to know how much is still in my dog's system at 3.8 hours. I don't have to check it at every hour on the hour. So it said yes, because there are parts of hours, time does not change only in whole increments. You might have something else put there. Would it make sense to look for when there's 35 milligrams of medicine and why? Well, I was thinking about this and I don't know what you wrote, but it would make sense. But I might want to know, hey, the doctor might say when you have 35 milligrams still in the system, you can give your dog a second dose. And so I wouldn't want to give my dog another dose until about 2.5 hours because that's when it's going to be about 35. There might be times when I want to know when there's 35 milligrams left. Okay. All right. Number 8, which of the function modeled in 6 and 7 are discrete and which are continuous? Here's where that conversation up here went in. If you decided that this one was discrete or continuous, you might have had a different answer for 6. But number 7 is definitely continuous. Number 7 is definitely continuous. Okay. Number 9, it says, what needs to be considered when looking at a situation or context and deciding if it fits best with a discrete or continuous model? Okay, so I do want you to pause the video and I want you to talk with this one with your groups. It says, what needs to be considered when looking at a situation or a context and deciding if it is best with a discrete or continuous model. What are some key words? What are some key ideas? What are some things that are clues that are going to help you decide if you're going to connect those dots and it's going to, or those ordered pairs and it's continuous, and if it's discrete. Go ahead and either discuss with your partner, or the sub can decide to discuss whole group. Go ahead and pause the video. All right, here we go. Number 10, it says describe the differences in each representation. So the first one we're going to think about is a table. And we need to decide in a table, can I tell if it is discrete or continuous just from a table? So let's go back up and let's look. If I'm looking at just this table, not anything else, but just this table, can I tell if it's continuous or discrete? What about when I'm just looking at this table right here? Can I tell if it's continuous or discrete? What about when I look at this table? The answer is not really. I guess I could possibly tell if I have them labeled minutes and books, or if I had it. But for the most part, from a table, I can't tell if a function is discrete or continuous. All right, just from a plain table, I cannot tell if it is discrete or continuous without some more information. Describe the difference. What about in a graph? All right, so let's go ahead and back up and look at the graphs. From this graph, can I tell if it is discrete or continuous? Well, yes, I can. If it's connected, it's continuous. If it's not connected, it's discrete. What about here? Well, in this one, it looks discrete because it's not connected. What about here? This one looks discrete because it's not connected. So from a graph, I can absolutely tell if it is continuous or discrete. So I wrote, if it is continuous, the ordered pairs will be connected. If it is discrete, they will not be connected. Okay. And last but not least, if I'm looking at equations, just from an equation, can I tell if it is discrete or continuous? And the answer is no, I can't tell from an equation if a function is discrete or continuous. If I just look at this function right here without any other information, I cannot tell if it's discrete or continuous. If I just look at, I didn't write one there, did I? If I just look at this right here, I cannot tell if it's discrete or continuous. And so I can only tell if something is discrete or continuous from the story or from the graph. I cannot really tell from the table, and I definitely can't tell from the equation. Okay. Last question, and we made it through. Which of the functions modeled in this task are linear? And that was problems 1, 2, and 3. The very first three about the books, those were all linear. And which were exponential or geometric? And those were the last two, the one with the dog's medicine, and this one right here, which was the paper. Okay. So we have lots of ideas here that we're talking about. Not only do we have linear and exponential, and we have tables and graphs and equations, but now we are trying to decide if things are continuous or if they are discrete. All right. Hopefully that helped with your understanding of continuous and discrete. Hopefully you did your homework like you were supposed to. Right now, your job is to go on to 2.2, ready and set. Those are your homeworks for tonight. All right, we already did the go. If you check down the go we did last week. So your homework is numbers 1 through 11, 2.2, numbers 1 through 11 on page 11. And let's go ahead and read over it really quick. State which situation has the greatest rate of change. So you're going to get two different situations, and you're going to figure out which one has the greatest rate of change for 1, 2, 3, and 4. Number 5 through 11, identify which of the following items are going to be best discrete or continuous. So that's going to be your first thing that you're going to decide. Is this discrete or is it continuous? Then after you've decided that, then determine if it is linear or exponential, which is geometric. Okay, so you're going to give me two different. First, you're going to decide, is this going to be best discrete or continuous? Then you're going to decide, is it best linear or exponential? And you're going to write those right here. All right. Like always, feel free to email me if you have any questions. When you get done, if you have extra time at the end, you can work on coloring your Grinch. We still have our Grinch that we need to do. Or you can work on other homework or play cool math games. All right. I miss you guys. Have a good day.